quadratic polynomial, a geometrical representation. Geometric representation. So let us consider a quadratic polynomial. For example, let us consider a quadratic polynomial p of x is equal to x square minus 3x minus 4. So we need to solve this. So let me assume let y is equal to p of x. This implies y is equal to x square minus 3x minus 4. So what we should do? We should try to get the points. So I have x and I have y is equal to x square minus 3x minus 4 here. So I want to get the points. So I want to move from minus 2 to 5. So I have the polynomial y is equal to x square minus 3x minus 4. When x is equal to minus 2, y is equal to minus 2 the whole square minus 3 into minus 2 minus 4. So I have y is equal to 6. So the value of y is 6 here. When x is equal to minus 1, y is equal to minus 1 the whole square minus 3 into minus 1 minus 4. So here it is equal to 0. So I have 0. So this is going to be one of the solution, one of the 0 of the polynomial. And when x is equal to 0, y is equal to 0 square minus 3 into 0 minus 4. So I have minus 4 here. I have minus 4. When x is equal to 1, y is equal to 1 square minus 3 into 1 minus 4. So this is equal to minus 6. So I have minus 6 here. When x is equal to 2, y is equal to 2 square minus 3 into 2 minus 4. So we have y is equal to minus 6 again. When x is equal to 3, y is equal to 3 square minus 3 into 3 minus 4, that is equal to minus 4. When x is equal to 4, y is equal to 4 square minus 3 into 4 minus 4. So we have 0 here. When 0. When x is equal to minus 4, y is equal to minus 4 the whole, when x is equal to 5, y is equal to 5 square minus 3 into 5 minus 4. So we have 6. So we found all the points. to plot the graph. So I have all the points. So let us try to plot these points in the graph sheet. So I have my graph sheet here. So the positive x-axis, negative x-axis, positive y and the negative y. Okay, 1, 2, 3, 4, 5 along the x, and along the y negative 1, 2, 1 to minus 5, minus 1 to minus 5, and along the y also 1, 2, 3, 4, 5, and along the minus y minus 1 to minus 5. Okay, so now I will try to plot all the points. So the first point is minus 2 and 6. X is minus 2, x is minus 2, and y is plus 6. So 6 here. So the point is here. The second point is minus 1 and 0. X is minus 1, y is 0. So the point is here. Okay. And the third one is 0 comma 4. X is 0, y is minus 4. So the point is here. The next one is 1 comma minus 6. X is so the next point is x equal to 1, y is equal to minus 6. So 1 and minus 6. Minus 6 is going to be here. The next point is 2 minus 6. So 2 and minus 6 again. X is 2, y is minus 6. So here it is minus 6. The next point is 3 minus 4. X is 3, y is minus 4. So here it is. Next point is 4 and 0. X is equal to 4 and y is equal to 0. It is this point. The last point is 5 comma 6. X is 5 and y is 6. So here, the point is here. So by plotting this point, we can able to observe that the points are not along a straight line. The points are not along a straight line. So it is not a linear polynomial, because the polynomial which we took is a quadratic polynomial. It is having a degree of 2. So if I plot it, it is not along a straight line. Okay. So now let us try to join all the points. So when we join all the points, it is like a U-shaped curve. What we can able to observe is a U-shaped curve. So this is very important. So we get a, when we plot this polynomial, we get a U-shaped curve. Sometimes we will get a inverted U-shaped also. We get a inverted U-shaped. Okay, this type of curve also we will get. So it is like a U-shaped or a inverted U-shaped. So this type of curve we call it as a parabola. Parabola. So it is called as a parabolic curve or a parabola. Which is called as a parabola? This type of U-shaped curve. So how we got this U-shaped curve? By plotting the points. By plotting the points. How we got the points? By substituting the values of x and getting the value of y. So this curve is called as a parabola. So what is the equation of this curve? The equation of this curve is nothing but our polynomial p of x. So p of x is equal to x square minus 3x minus 4. This is the equation for this parabolic curve. For this parabolic curve, this is the equation. Okay. So here we can able to observe very clearly that this curve is intersecting. So this curve is intersecting the x-axis at 2 points. Where are those points? This is one of the point, this is the other point. It is intersecting at 2 points. Where it is intersecting? It is intersecting at x is equal to -1 and it is intersecting at x is equal to 4. So these two are the zeros. These two are the zeros of the polynomial p of x is equal to x square minus 3x minus 4. Okay. So the zeros of the polynomial are the zeros of the polynomial p of x is equal to x square minus 3x minus 4 or x is equal to -1 and x is equal to 4. So how many zeros we have? We have 2 zeros. We have 2 zeros here. We have 2 zeros. There are 3 cases in quadratic polynomial. So the first case is case 1. Case 1 is p of x, the polynomial p of x intersects or cuts x-axis at 2 distinct points. At 2 distinct points. So the graph will be, if this is the y-axis and this is the x-axis, the polynomial p of x, if we plot the graph of the polynomial p of x, the polynomial p of x will be either it will be like this or it will be like the inverted U shape. So here we can note that the parabola, the curve that is p of x. So this is our curve p of x. This is our curve p of x. It is intersecting the x-axis. It is intersecting the x-axis at 2 different points. There are 2 points. So point A, point A dash. Similarly here also point A, point A dash. So this is the first case. So the second case is case 2. The polynomial p of x intersects x-axis at only one point. It will intersect the x-axis only at one point. So how does the graph will be? The graph will be something like this. It will be like this. So it is intersecting only at one point, or it can be on the other way also, the inverted type. It can be like this also. So here it is intersecting at only one point. At only one point. Here it is intersecting at 2 distinct points. Distinct means different. Here it is 2 different points. Here it is two different points, here only one point. And there is one more possibility. There can be one more possibility also. So P of x is either completely above x-axis or below x-axis. It is completely either above or below x-axis. How the graph will be? The graph will be like this. So if it is completely above x-axis, it is like this. It is not intersecting at x-axis. So our x-axis is here. It is not intersecting at the x-axis, or it can be below also. It can be below like this. Here also it is not intersecting the x-axis at any point. So here there is no zeros. No zeros means there is no solution for this polynomial. Here we have two different solutions, that is two different zeros. Here we have only one zero, that is only one solution. Here there is no zero at all. So it does not cut the x-axis or intersect the x-axis. So there is no zero for the polynomial. That means there is no solution. No zero means it is no solution. Two different points means, so here we have two solutions. Here we have two zeros, that is two solutions, two different solutions. Here we have only one zero.